Okay, let's see. Let's get started. Cool. You guys were all here, so you've seen this one. The only difference is that this one is a little technical compared to the previous one where it's more conceptual. This one, actually, you're pulling out your keyboard and doing some typing of the code. Like we did last time. If you were here last time, you know that we did some Ethereum stuff. We talked about the EVM. This is this shared machine sort of replicated across computers all around the world. And you can send requests for it to do things for you. Requests cost money, so you gotta find a way to pay. How do you pay? You use the native currency, ETH. That's sort of, this thing is currently trading at 1,600 something per ETH. You have smart contract. These are programs that live on the blockchain. What can smart contracts do? Applications include decentralized finance, NFTs, DAOs, tokens. Now, the question that we didn't answer last time is how do you create these applications? Obviously, the answer is some level of code, but how does that actually look like? So there are two ways to interact with Ethereum or EVM. You can do simple actions such as send money, read data, use an existing contract. You can largely perform these tasks within a wallet. What is a wallet? We'll show you in a bit. However, if you want to put a smart contract on the Ethereum, then you need to there's additional tools that you would need beyond a wallet to do that. And also, these are some description of the smart contract. You have these are independent entities on the blockchain. They almost behave just like a person. So you and a smart contract, you guys are equal in front of the blockchain. These can own assets and smart contracts that interact with other smart contracts. However, a smart contract cannot change its code. It has good and bad consequences because of that. And it also doesn't do things automatically. So you need to be sort of the driving force. So a smart contract doesn't act by itself, but you can ask the smart contract to do something. I had a slide that, anyways. So just fast forward a little bit. Essentially, we're alluding to the fact that you would need some sort of tool, just like a good baker needs a bakery to bake good breads. So this class in particular, we're going to go over some tools that you'll be needing for blockchain development and creating smart contracts. So what does the life cycle of a smart contract creation or writing smart contract look like? First, you come up with idea. You come up with something you want to do. You want to ask the blockchain to do. Right? And then you turn this idea into code. What is this code? Commonly, we use this language called Solidity. And then you turn code, which is human readable because it's like English essentially, into something that machine understands better. Here it's a format called binary code. Obviously, as you're writing this code, and if your code has bugs, right? It's just like write an English sentence and it doesn't make any sense. It's not comprehensible. Then you can find that out before you publish things onto the blockchain. So as you're coding, you can sort of try to run them and try to test them and see if it behaves correctly as you want it to be. So after that step, you're okay with your code. You think all your logic, everything you want to do is captured, in these sort of elegant format. You upload the binary. You compile the code and you upload the binary to the blockchain. And at that point, you and everyone else can use the smart contract and use this app because this is a shared computer. This is what Solidity code looks like. So we won't dive too much into what exactly each line means. And there is a specific syntax to it. Some of the things I pointed out with the text in green comments is that at the beginning you define sort of which convention are you using, because every edition of Solidity has different syntax, different conventions. Then we have this contract called Hello World, right? You can put the name of your choice there. These contracts can store internal variables. So here we have a string, which is like a text called message, and then you have this function constructor, which is always called at the beginning. So whenever you upload the code to the blockchain, and it's only called once because you only do that once. And then you have some functions, essentially things you can ask the code to do. such as set message and get message. So we're going to talk about, okay, so we need to write code. And we can't write code just like on a piece of paper, right? Like we can't expect that to get to the blockchain somehow. So you need tools. Two options. First option is you use something called Node.js. Does any of you have background in programming? Are we familiar with what Node.js is? Not really. Cool. I didn't expect. So Node.js is this code library that helps you write code. And Hard Hat is sort of one of the Brendan, could you close the door? Hard Hat is like this blockchain specific tool that you can install to help you write code. This is generally the recommended practice. And if you are actually serious about developing, this is what you would get. However, as we mentioned, it has a lot of overhead to install, especially for people who don't have experience with a lot of CS or a lot of configuring environments. So today we'll be demonstrating option 2, something called Remix Solidity IDE. IDE stands for Integrated Developer Environment. So it's integrated, which means like it's there, it's already done. We don't need to tinker with it, and it runs in your browser. So as long as you have a working browser, we're good to go. So yeah, so we're very soon. We've already arrived at our hands-on activity. So go to this website, remix.ethereum.org. And actually, let's do this. So you should see something like this. And let me know if we're all there. Maybe raise your hands. You're there. Okay, cool. So this like accept. So all the messages doesn't really matter here. It has some welcome messages. We can just skip that for now. This is what we'll be guiding you through. You can close that out. And so you see we are at File Explorer. So this is almost simulating a folder on your computer, except now it's a folder sort of in this integrated environment. So click the plus sign next to workspaces. And it shows create workspace. Sorry, I actually need to move the screen share to a different place. Give me one sec. Share. Wait, okay, cool. Yes, so choose a template and we want to choose ERC20. You don't have to check any of these. Actually, you know what? Let's check the mintable box. And then, okay. You can, name workspace name, whatever's, but the default one works. Okay, so we are in, we created this template. So what's a template? It's essentially, right, like if we want to make sourdough, right, like there's a set of recipes, right, you can probably start with. You can add your own inspirations. You can, put whatever cinnamon or whatever, your house special ingredients, but this is what you start with. So your smart contract actually lives in the file under this folder called contracts, and specifically my token. So if you click on that, great. This is what you should be seeing. So it's very, this is super elegant, right? There's only like, 10 lines. This is actually not where all the code lives. So this is importing. So it's like, copying the content from another file. And then here what we have is just the bare minimum. Specifically, you can name your token. So under ERC20 parentheses, my token, MTK, give it your name of choice, right? Like maybe put your name into it. I'll say like Intel token. That's my name. And then for the others parameter, I'll just do INT. The first field is the name of your token. And the second field is sort of the ticker symbol. It's just like, USD. And what we're trying to do here is launching your own cryptocurrency. If you came to our Bitcoin and Ethereum workshop, you know that one of the problems why Ethereum appeared is like, we don't want to be building new blockchains all the time. right? If I just want to launch a cryptocurrency. So, here it's like that easy. We can launch our own cryptocurrency. However, there are a few more steps. And then the mint function here, essentially it allows you to arbitrarily send people. As the owner, you can arbitrarily send people like fake, whatever token that you create. And yes, what's next? Okay, cool. So now you have this code. So this is all we need for the smart contract. What we want to do next is compilation. So we need to compile this code. So turn this code from, close to English format into like data that machine can comprehend more easily. So if you go down on this third tab here, and you click compile my token.sol, and it's gonna say ready. Okay. If you guys just got in, so we're sort of trying to create your own cryptocurrencies on Ethereum. Just go to this website, and Brendan, you can help them catch. Okay, great. So at this point, you've compiled your smart contract. If you go back to the first tab, so File Explorer, there's actually a lot of sort of new content that's being created, specifically under this artifacts folder. So before, under the contract folder, there's only my token, right? I don't know if you remember, but you can take my word for it. This was the only file, but now there's a new file called artifacts. Are we all following? Good. Good. Okay, great. So there's actually a few new files in here, right? So first, you have this thing under build info, and in build info, you have this one of the output under right here. It says ABI, and we'll talk about what ABI is. ABI essentially allows other smart contracts to talk to you, right? It's like I go out into the world, I speak Chinese and English, and if someone wants to communicate with me, they need to speak Chinese or English. So here I'm declaring that here are the languages I speak. If you want to talk to me, please use these languages. That's what ABI's purpose is. And then there's this file called mytoken.json. And if you scroll down a little bit, you're able to see that one of the data is bytecode, as we said. So everything under bytecode here is sort of formatted in a way that computers can understand better. So you can see that the code that we had, which is pretty short, but it's getting translated to all these machine instructions. So computers essentially need to run these back to back, right? Run this one and run the next one, run the next one, run the next one. That is what our code translates to. I think that's it for this part. Cool. Okay, going back to this. Any questions? How are we feeling? Was that too fast? Okay, student one, could you, what's your name?
Siobhan.
Siobhan?
Siobhan.
Siobhan.
Yeah. Don't worry, you can.
Okay, Siobhan. Tell me what just happened.
What just happened?
Like, what did we walk through, sort of, with the remix?
Okay, so we tried to create our own. I remember we renamed it.
Yep.
When was that? Okay, so we started off trying to create a workspace.
Mm-hmm.
And then we chose the template ERC20.
Yes.
And then I remember we chose Mutable or something.
Yes.
And then
yes.
we have the option to change the name of the workspace.
Yes.
And then we tried to compile the mytoken.json thing.
Yes.
Yeah. And then we came back to artifact. And then we just went through build info, all the codes.
Mm-hmm. Yeah, we took a look through what's in artifacts and what got generated after we clicked compile.
Mm-hmm.
So here is a more sort of graphical representation of what we just did. sort of up till the middle of the slide. So start from the left, we start with the code, right? So we wrote the code in Solidity. This time we sort of generated from the template code. So like this is a code other people have written. We are only changing like a few things, right? Like this cryptocurrency, we're changing the name of it. And then we click compile, the second stage, right? And then the compiler, it's a piece of software that translates code from the more human readable version to the computer understandable version. And then we get sort of three pieces of files. We have the bytecode illustrated here, and then we have ABI and metadata. Bytecode is the code that the EVM will be running. So this eventually gets sent to the network. What is ABI? ABI, as I said, it's sort of it tells other smart contracts what language I'm speaking. So if you want to talk to me, here are the languages I speak, and more specifically, for example, in our function we have one thing that we can do. We can mint, right? But if you want me to mint something, what should you do? You need to tell me. You need to say function mint, and then first argument is some address. Second argument is some amount. So I will tell you exactly how to speak to me and what exactly to tell me so I can do the things you want for you. So that's ABI, application binary interface. So, and then lastly, you have some metadata. And metadata, it's like data about the data. It essentially includes information about the smart contract. So for both API and metadata, it's optional whether you want to publish them to the Ethereum, right? Whether you want to let the public know, or you can just hold on to it by yourself and not let everyone know. But then people wouldn't know what this smart contract is about. People wouldn't be able to talk to the smart contract. And so next, what we're trying to do is, okay, so we have the code ready. All we need to do is upload this to the blockchain, and then everyone will be able to access it. And once you upload to blockchain on Ethereum, then you're able to use tools like Etherscan, and everyone can see it. But wait, we're not there yet. Because why? Because the blockchain doesn't know who you are. And also don't kill your remix pitch. Because right now at this point, even though you are someone in the real world, but blockchain doesn't know who you are, and thus you can't do anything on the blockchain. Blockchain needs to, just like we talked about last time, everything you do on the blockchain, you need to sign for it. If blockchain doesn't know who you are, right, like it doesn't work. So let's go ahead and get you an ID that's going to, you're able to show this everywhere on the blockchain. And this is a blockchain wallet. What is a blockchain wallet, and specifically an Ethereum wallet? Ethereum wallet is, as we discussed, right, like it supports simple actions that you can perform on the blockchain, such as send transaction, send people money. And you can look at your own balance, how much ETH or how much NFTs I have. And it has an address. It has a public address, just like your driver's license ID, like your passport ID. It's a way to uniquely identify you. So when other people refer to you, they use that ID. And underneath, it uses public key, private key cryptography. So the public key turns into your address that everyone refers you to as. And then the private key, you hold on to yourself. And it's almost like a password, right? Like you don't want to leak this because that is the only way the blockchain knows who you are. It's by someone knows the private key to this account is the owner of this account. It's just like, to your Facebook login. Someone who knows the account username and password to this account, Facebook thinks you are the owner of the account. Cool. And so we don't need to scan this QR code because we'll walk you through, but it contains a link to how to set up a wallet for yourself. So now we'll go into setting up your account, your MetaMask account. All right, so let's go extended. And let's switch the screen share. Cool, you see it? Awesome. So you would go to this website, metamask.io. Let me know when you're there. Good. And then, whatever browser you use, usually Chrome. So you can download for Chrome, and it's going to take you to the Chrome web store. And then here I already installed it. So, but you can just click install or get whatever it is. Once you do that, it's going to pop up. Well, it's probably going to ask you yes, no, whatever. Just like common sense applies here. Here on the top right, you can see this like Fox logo showing up. If it doesn't, click on this one next to it. Right, this is like a puzzle piece, and then click the pin icon, so you're able to see it without like clicking into the extensions menu. Great. And it should actually automatically take you to this website, MetaMask right here. Are we all there? Good, good. By the way, how many people have wallets? Okay, cool. So you guys, let's bear with me for a second. So, okay, let's get started. Create a new wallet. And it's gonna have some, messages. You just say agree. Create a password. This password is like a second level of security. So for the purpose now, like it doesn't have to be too secure, right? I'm just gonna use a simple password. And check the box, create a new wallet. All right. Let's see. Cool. Good. I see a slight nod from everyone, so I'm going to assume that's working. What does it say? Secure your wallet? Oh. Secure your wallet? I'm actually kind of confused.
I read somewhere that you shouldn't choose this because it's like sometimes it's like
MetaMask funds if you ever lose
What?
access. It's important that you secure your wallet.
Let's just watch it.
MetaMask is a new way to connect to sites and applications. On traditional websites, a central database or bank is responsible for controlling and recovering your accounts. But on MetaMask, all of the power belongs to the holder of a master key. Whoever holds the key controls the accounts. Your secret recovery phrase is your master key. It's a series of 12 words that are generated when you first set up MetaMask, which allow you to recover your wallet and funds if you ever lose access. It's important that you secure your wallet by keeping your secret recovery phrase very safe and very secret. If anyone gets access to it, they will have the master key to your wallet and can freely access and take all of your funds. To secure your MetaMask wallet, you'll want to safely save your secret recovery phrase. You can write it down, hide it somewhere, put it in a safe deposit box, or use a secure password manager. Some users even engrave their phrase onto a metal plate. Nobody, not even the team at MetaMask, can help you recover your wallet if you lose your secret recovery phrase. If you haven't written down your secret recovery phrase and stored it somewhere safe, do it now. We'll wait. And remember, never share your secret recovery phrase with anyone, not even us. If anyone ever asks you for it, they're trying to scam you. That's it. Now you know what a secret recovery phrase is and how to keep your wallet safe and secure.
Okay, so if you click remind me later, essentially, they're going to store the secret recovery key in your browser. Whereas we're going to go the route of secure my wallet. So click secure my wallet. Okay, this is going to be a burner wallet for me. So I'm going to click on this and you'll have access to this wallet. Doesn't matter. I don't have any real money in this. So that's fine. And so, okay, reveal secret recovery key. What I'm going to do, I'm going to take a picture on my phone because it's going to ask you to sort of reiterate, what's the word? To repeat these secret recovery keys in the next step. So if you actually think this is your last wallet and it's the wallet that you'll be putting tens of thousands of dollars into, don't do it. Write it down on a piece of paper, right? Don't take it, take a screenshot or take a picture like me. But for the purpose of tonight, I recommend you just take a picture on your phone. And once you've done that, click next. Now, so they're going to check that you have actually did the write them down. So I'm just going to input these. Right. Wait, what? Why does it not say continue? What? Was that wrong? No. The fuck? All right. What's going on, Brendan?
I think it might just be like a bug on the MetaMask end.
Oh no.
Very unfortunate, but bugs do exist in the world of software engineering.
Right.
Oh, isn't it Trey?
Oh, it's Trey. You're right. Thank you.
An error. Either way.
Right. Troy is not that common of a word, I guess. There we go. So we talked about the concept of a secret key. Secret key it's some kind of a hash. So it's like some random bits of string, right? So there's actually an algorithm that translate what you just saw, these like human readable words selected from a word bank, and then turn them into a secret key. So you don't have to remember a long string of, scrambled words, scrambled bits. Rather, you can try to remember and write down something more legible. And then, okay, cool, got it. MetaMask install is complete. Cool. And then now, whenever you click on the top right, this fox icon, if you don't, just pin it. And then, okay, whoa. Come on, it should, yes, there should be a pop-up. So you should be able to see this, right? And while we're at it, please click this dropdown and add network. And we're going to do, wait, what, Gorley? Oh, wait, it's in general. Wait, Brandon, where's the like turn on test net? Oh, okay, yeah. So go to settings, advanced, and then show test networks. Are we all able to find that? Cool. And the purpose we're choosing test network is because everything on Ethereum costs money, and I'm not giving you all $10 to do the demo. So we're going to use fake money. So right now we're jumping to fake blockchain world. Everything is the same. It's just that money is fake money. So it's easier to work with. And now if you click the drop down on top right, you should be able to choose this blue one, Gorley Test Network. And we're good to go. Right. And then, so once you're at Gorley Test Network, come to this webpage, gorleyfaucet.com. Gorleyfaucet.com. As we just said, right? Everything costs money. You send a request, you deploy contract, interact with contract, everything on Ethereum costs money. So now we want to show you how to interact with the blockchain, and we're not giving you free money. So we switch to this fake blockchain world, and then we're gonna, get ourselves some fake money. What you do is, I actually have the slides for this. Cool. Yeah, this is all just some general tips. Only so don't reveal your secret key, and if you lose it, it's gone forever. And only approve/sign transactions, agree to transactions that you know what's going on. Okay, so Gorley Faucet. So it's gonna ask you for sign up for free here. Otherwise, you can't use it. So sign up for free. You can log in with a Google account, as it might ask you additional stuff. I'm just logging in with my Google account. Right. So once you've logged in, are we all there? I'll wait for another minute. Whoa, what's going on? Another shooting? We're good. Oh, two-factor. Okay, I'm gonna assume that we're all there. So we need to put in our wallet address. Where can we find our wallet address? If you click on your MetaMask and wait for the extension to pop up, right here in the middle, if you just click it and it says copy to clipboard, it's going to copy your wallet address or public address. And then you come back and paste that into this box. Once you do that, send me ETH. And it should do a very creepy animation. I don't know why it does that. It's kind of like, did I just get hacked? Now, if you go back to your wallet, magic, now I have 0.2 Gorley ETH. And in real world terms, that's how much? That's like $300. So obviously it's fake, but you know, if we're on the real blockchain, that would be like $300 something. So now we have money, so we can go around and do things on the blockchain. Are we all following? Anyone who needs more time?
Need more time.
Okay, cool.
Yeah, let us know if you run into any issues.
Brendan, do you want
It should be a very straightforward process. Yeah, raise your hands if you have any issue.
So another thing that's remarkable about what just happened there, right? Like blockchain is truly, right? Again, we talked about how everyone on the blockchain agreed with everything that's happening, and everyone has to, so everyone believes in like, you know, everyone has how much money, right? So just now, after I click, you know, send me ETH, the blockchain, the test network all around the world now knows I have 0.2 ETH, right? That's remarkable. That's like using your credit card, right? Using Visa or using MasterCard, right? Once you swipe that and then some, you know, somewhere in the computer system, everyone's agreeing, okay, cool, this person just spent $200. So it's pretty magical. Do we still need more time?
Yeah.
Okay. Oh, okay. Yes.
There's just like a question related to that. So like if the blockchain's always growing and needs more and more data, like how are we able to like store all of this like efficiently?
I always love to answer this question. So luckily that we don't, so like for example, from time t to time t1, there are something that's changing, right? But not everything is changing. So let's say like there is somewhere in blockchain, there's an island that there stores a letter A, and the next time, you know, time frame, it's still A, right? So we don't have to store that change. So this is really like sort of a storage optimization problem. But essentially, to put things in perspective, the entire size of Ethereum network is like 3 terabytes. It's on the order of terabytes. Like it's less than 10 terabytes. And you know, for the time being, we're okay.
Does it have potential to grow a lot, or does it kind of stay the same?
I can buy 100 terabytes for $2,000. So not a problem for now. But what does that mean? It's like, but if, right, at the very beginning, anyone can run Ethereum, like computation is another problem, but storage wise, everyone can run blockchain on their computer, right? Like, I'm sure your computer has like 100 gigabytes of storage, right? At the beginning, maybe Ethereum is only 100 gigabytes large, right? So we can have more decentralizedness. So, right, it's like, you know, it takes more malicious player, more hackers trying to take down the network. But as the hardware requirement grows, right? Not all of us have 3 terabytes of storage space on their computer. So now there's only a concentrated few, only people who are willing to invest and buy, big hard drive servers are able to run blockchain. Now the problem is like, okay, now we have less people on blockchain and we have richer people on blockchain. Then potentially it's easier to convince all of them and take down the blockchain. Right, so that is a potential concern. So one direction that, as blockchain designs go, we want to make sure that the hardware requirements for at least, a popular philosophy is we want to keep the hardware requirements low so that everyone can run blockchain. And the most extreme case is maybe in 20 years, we can run a blockchain node on our phone. But that's not realistic today. Email problem, are we
Yeah, there you go.
good?
Okay, yeah.
Okay, cool. Sounds good. So you should have 0.2, or if you've worked with this before, more in your account. It should show 0.2 go to the ETH. And at this point, let's go back to Remix, right? We had our smart contract sort of all built, all compiled, but we haven't uploaded to the blockchain yet. So we'll do that right now. If you navigate down to the 4th tab, where it says deploy and run transactions, we need to make a few changes here. Sorry, I need to project the right thing. So yes, so there's that. And let me change the, oh, I've been sharing the other screen the whole time. Cool, doesn't matter. Okay, wait, hold on, let me just share this screen real quick. Okay, cool, and then go back. The other one. Cool, okay, so what do we need to change? First, the environment. We don't want to use Remix VM. It's good for testing, but since we're trying to deploy to a real blockchain network, a real fake blockchain network, but it's blockchain. So we're going to choose inject the provider, MetaMask. And then it's going to ask you a permission to connect with MetaMask. It's almost like people asking for your permission to see your ID, right? Because you don't want to show your ID to just anyone. And here it's asking, MetaMask is asking you, is it okay that I tell this website who I am? Cool. And once that's done, this account should automatically pop up, and you should see that you have 0.2 ETH to spend. The gas limit and value, these don't have to change that. Here it says like no compiled contract. So wait, PC main. Let's go back to right. So this deploy. Okay, so we don't see the deploy sign. So we need to go back to the 3rd tab. And make sure you choose your mytoken.sol in the editor view. And then on the left, the 3rd tab, you should be able to see compile mytoken.sol. So make sure to compile that again. You see a green check. And you go back to the 4th tab. And now you just click deploy. Are we all here? Questions? No questions? And then you click confirm. So what you see here is that MetaMask asks you to check exactly what the website requests you to do on the blockchain. So it is to deploy a contract deployment, and estimate gas fee. That's how much it costs for the blockchain computer to run your request to install this new program. And there's also other fees, and then it's calculated based on market price. That's why you saw it just flash and then change. And I'm going to click confirm because it's fake money. And at the bottom here, you should see some progress. Cool. So we see a green check mark. That means the request has been sent to the blockchain. Blockchain has confirmed it and included in a new block. And we're able to check that by click on this link, view on Etherscan. Etherscan is this service that allows you to inspect the state of blockchain and look up transactions, look up people's accounts, see what's going on. And you can see that this block has a timestamp, 15 seconds ago at this absolute time, and this is my account. It should be my account. Let me double check my MetaMask. Right, it's like ends in A98, and it's A98. So sent from my wallet, it's I who sent it, and then I created this contract. Great. And you're able to see a screen like this for everything anyone does on the blockchain. So that's why everything is public. And it makes makes a lot of like criminal activities very easy to track. And now if we go back here, you will see a scroll down on this left tab here, you can see deploy contract. And this is a list of everything you can do with this smart contract. So specifically, because we launched a cryptocurrency contract, we can look up so that everyone has accounts. Everyone on the blockchain has an account, but they all start with 0. So let's just first check how much money I have in this Intel token. So I'm gonna again copy my private public key here, and then it says balance of. Actually, we do have a page for this, I believe. Yes. So balance of, and I'm gonna copy my public address in. You should try to do the same, just so that you get a feel. You click that balance of, and you get this a number back 0. I have nothing. Next, I'm going to use this program to give myself some Intel token. So I'm going to come to this function called mint. And you can see that it asks for first your address, and then how much you want to give yourself. I'm going to put in my address, comma, 100. And then I'm going to click mint. Because this, again, is a action that we want the blockchain to execute, and we're changing the state of the blockchain. So we need to pay a fee for it. Again, I click confirm. It's running. It's blockchain is trying to figure things out, and we should see a check mark in a bit. Great. So that function is run successfully, and blockchain has picked it up. And now again, let me look up the balance of myself. Balance of, we have 100, and everyone in the world knows I have 100 of Intel token. Guess what? We can sort of look at it using Etherscan. So this was the transaction that I just executed. I called the mint function and gave myself 100. So you can see that this is me and in A98. And then I interact with this smart contract, and it put in the format of coming from 000. It's like, this is like God, essentially. It's like things coming out of nowhere to me, to my account. And then the denomination is a little messed up because the number 10 there is actually, the number displayed here is actually whatever number times 10 to the negative 27 or something. So that's why there's a lot of zeros here, even though it displayed 100. And this is how much it costs to run that transaction. Okay, I want to give you guys all a little bit of time to run what I just did on your computer as well. So come down to deploy contracts, and first check the balance of yourself, putting your public address. It should be 0. Then you click the mint function, putting your address, comma, some number. And once it's confirmed, come back to balance of, check your balance again and see what happens. Did it work? Yeah. Actually, did it work?
Like this.
Yeah. New coin. What's your coin name? Is this just 1.1?
160.
160. Oh, nice.
I was 160 actually.
Oh, okay.
Unlucky. My quick question, like what types of like operations cost like money to like do? Like what types of transactions cost money?
In a sense, only things that manipulates the state of the blockchain cost money. For example, we are actually, when people then look at the blockchain again, they know that I have 100 more tokens in my account, right? Whereas if you just check my token, how much token I have, it's because it's already there, right? I'm just reading data. So I'm not modifying the blockchain at all.
So then it's like free, right?
Then it's free. If it's something that's readily observable, then it's free. If it's something that blockchain needs to do some computation, then it costs money. And then there's there's a few different classes of computations, right? There are computation that is like you do the computation and you store the result onto the blockchain, such as adding 100 tokens to my account. But you can also do like just, okay, blockchain, what is 3 + 4? Blockchain says 7, but you don't want the answer stored on the blockchain. So technically, you're not modifying the state of blockchain from T to T1, right? But because you're asking blockchain to do work,
Yeah.
it costs money.
Does it just depend on like how computationally intensive it is for how much?
Absolutely. It depends on through what instructions the computer have to run.
Okay.
Yeah. So yeah, so you guys all had a taste of Solidity, and if you want more Solidity, we don't have it. If you guys have strong interest, we'll do it in the future. And we have some additional resources that'll be included in the slides. That's it. Thanks for coming to the workshop. Any questions? Happy to take questions.
So how do
You can again do it all.
how programming respond? Did you